You are welcome to Chapter 5, Selecting Innovation Projects, taken from our main topic, Technology Strategy for Managers and Entrepreneurs. Today's learning objectives identify the different ways that firms manage the uncertainty of innovation, describe the different tools for making decisions about innovation, use the analytical hierarchy process to evaluate innovation projects, calculate the internal rate of return, payback period, and net present value of innovation projects, conduct an accurate options analysis of an innovation project, explain why fundamental options analysis is often better than net present value calculations for evaluating innovation projects, use a decision tree to make decisions about innovation projects, and explain why companies need to manage product portfolios. Managing uncertainty. Companies manage uncertainty through strategic actions such as seeking high enough returns to justify the cost of bearing it, minimizing the magnitude of their investment in non-salvageable assets by using generic inputs, starting on a small scale, and turning fixed assets into variable ones, maintaining the flexibility to change strategic direction, and relocating it to those parties more willing or able to bear it. Decision-making tools. Are qualitative decision-making tools compare projects on basis of scales and words. Are quantitative decision-making tools evaluate projects on the basis of numerical calculations. Are comparative decision-making tools pit projects against each other, and scoring decision-making tools compare projects against standard scales. What is a checklist? A checklist is an example of scoring model. Checklist is used to evaluate whether or not a project meets specific criteria. A checklist determines if the presence or absence of essential criteria influences a project's decision to proceed. A checklist for selecting software. The checklist in the table is used to check if different dimensions of the software were present. Looking at the list in the diagram, we can see a list of software dimensions, and we can also see a column to show if they're present or not. So looking at the dimension column, we have low cost to purchase, low cost to staff, low cost to support, low cost to train employees to use, easy to customize, high level of reliability, high level of interoperability with other systems, high degree of scalability, high level of security, and long expected life. The checklist will then go through the list and determine if any of the dimensions are present or absent. Analytical hierarchy process. An analytical hierarchy process is a decision-making tool in which a problem is broken down into hierarchy of different criteria and choices. It also involves ranking the importance of each criterion. Analytical hierarchy process. As we can see in the list, we can see that the analytical hierarchy process goes through compatibility with the existing system. It also shows the difficulty in learning the same system. Net present value. Many quantitative decision-making tools are based on the analysis of discounted cash flows. Net present value calculation estimates the value of a project today given the amount and timing of cash flows and inflows and the discount rate. Internal rate of return calculation. Internal rate of return calculation estimates the return on a project given the level of expenditure and the timing and amount of cash inflows and outflows. Present value of future cash flows. The process is divided into 4 columns. The first column is the year and the second is cash inflow. The third is present value, while the fourth is computation. So as you can see, in the first year, we have the cash inflow of $1 million and we have the present value of $909.91. And we also have its computation as PV equals CI over 1.10. The same goes to year 2, year 3, year 4, and 5. And finally, we have the total as shown in the table. Payback period. The payback period is divided into 3 columns. The first is the year, the second is discounted cash inflow, and the third is cumulative discounted cash inflow. We can see the first year, the discounted cash inflow is $909.91, and the cumulative discounted cash inflow is $909.91. We can also see year 2, year 3, year 4, and 5 payback period as shown in the table. Internal rate of return. Internal rate of return is the discount rate that yields a net present value of 0. It indicates how high a financial rate of return a project will generate. Internal rate of return also estimates whether the project provides enough premium to justify bearing uncertainty to undertake it. Internal rate of return. Looking at the table, we can see the year. We can also see different rates of return. In this case, we have 0, 1, 2, 3, 4, and 5 different rates, as well as the total. So within a year, we're looking at an income stream. We're looking at present value at a 5% discount rate. We're also looking at present value at a 6% discount rate. And we're also looking at present value at a 5.675% discount rate. For income stream at 0 is $850,000, at 1 is $200,000, at 2 is $200,000, at 3 is $200,000, at 4 is $200,000, and at 5 is $200,000. Total is $150,000. That's for the income stream internal rate of return. And we can go on and on for the present value at 5% discount rate, present value at 6% discount rate, and present value at 5.675% discount rate. Real options. Real options are tools that can be used to overcome the limitations of discounted cash flows analysis. It provides the right but not the obligation to make a future investment by involving such as option price, which is the cost of developing a new technology, as well as exercise price, which is the cost of exploiting the technology. Advantages of real options. Real option limits decision making to information known at the stage at which the decision is being made. It helps a process maintain flexibility and avoid committing valuable resources to infeasible alternatives. It also permits a process to postpone decisions until the uncertainty is reduced. Real options evaluation for a wireless PDA. As we can see in the flowchart, we can see different options such as investment in research project outcome, investment in product development, and commercialization outcome. Starting with investment in research projects, we can see there's an option that says yes or no. If yes, it goes to the next stage, and if no, as we can see, it goes to the bottom. The next is research project outcome. If it is yes, it goes to the research project outcome, such as excellent, good, or poor. If it is excellent, it goes to the investment in product development. Could the answer be yes or could the answer be no? If the answer is yes, it goes to the commercialization outcome. Going back to investment in research project, if the research project outcome is good, it goes to investment in product development. If it is yes in investment in product development, it goes to commercialization outcome. And if it is no, it is cancelled. And finally, going back to the investment in research project, if it is yes, and if the research project outcome is poor, it goes straight to investment in product development. And if it is yes, investment in product development, it goes straight to commercialization outcome. And if it is no, it is cancelled out. Scenario analysis. Scenario analysis is the representation of investments under different assumptions about critical factors that influence those investments. It facilitates identifying the sources of uncertainty rather than acknowledging them. It can use Monte Carlo simulation to create a probability distribution of outcomes through computer software that experiments with randomly selected values of inputs. Decision tree. A decision tree is a visual representation of decisions and their effects. It can be used to establish the following criteria such as outcomes, costs, and risks. A decision tree. A decision tree can start by choosing R&D projects. Looking at the R&D project in product 1, a $4 million was invested in the R&D. It has 70% chance of having a $1 million invested in manufacturing. It also has 30% chance of failure. And if $1 million is invested in the manufacturing, it has a 10% chance of 30 million sales and 70% chance of 20 million sales and 20% chance of 0 sales. Going back to the R&D project in product 2, if a $2 million is invested in product 2 R&D, it has a 100% chance of having $1 million invested in manufacturing. And moving on from manufacturing, it has 40% chance of 50 million sales, while it has 60% chance of 0 sales. Portfolio management tools. This helps businesses develop multiple products to coordinate the various stages of the innovation process. It assists in determining the proper sequence of those tasks and the resources required at various stages of the process. It also helps decision makers to decide the order in which to pursue projects and to allocate resources between them for optimum resource constraints. Project maps. Project maps are a portfolio selection tool that helps to manage the allocation of resources across various platforms. Project maps link product development efforts to farm strategy. It helps companies to avoid overcommitment to innovation. It helps sequence product development efforts to utilize resources effectively. It also improves the management of product development personnel. Managing product development projects. As we can see in the diagram, is divided into two. On the y-axis on the left is the degree of process change, and on the x-axis right at the bottom is the degree of product change. We can see the degree of process change going up to breakthrough projects in the y-axis, and we can also see in the x-axis degree of product change, such as platform projects and derivative projects. We have now come to the end of the 5th chapter. Thank you all and see you in the next lecture.